2. Hi, everyone. Thank you in for tuning in today. This is Professor Yaw Adu-Gyamfi, and he is an assistant professor at the University of Missouri in the Department of Civil and Environmental Engineering. And today he's going to talk about AI and automation in transportation. So take it away when you're ready.
All right. Thank you, Julia. Hope you can all hear me fine. Sorry for the technical difficulties. My name is Yaw Adu-Gyamfi, as Julia said. Um, I'm an assistant professor in civil engineering at the University of Missouri. So I will dive a little bit into my background, um, what I do, and then I will like to talk to you about two projects that I'm excited about sharing with you all. Um, if you see me moving my eyes off the screen, it's because I have two different screens. Uh, so there is a screen that I'm using to share, and there's one that I'm talking to. So if my eyes are off you, it's just because I'm looking at the screen that is being used to present.
Mhm.
So a little bigger background about me. I was born in Ghana. I was raised in Ghana. I did my undergraduate degree in Ghana, and so I lived in Ghana till I was about 23 years old, and then I moved, immigrated to the United States for my graduate studies. So that was my very first flight. I'd never been on a plane, and my first flight was to United States. I was going to grad school at University of Delaware. Um, Very tiny, 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 tiny state. You can see the red shaded color there. Uh, it was a good place to be. I went to UD, and then from there I went to I did go to further my studies in University of Virginia and then Iowa State University. So these are the universities that have educated me, um, and now I work currently at Mizzou, University of Missouri. My work here primarily, or my research, I teach, of course, because I'm an assistant professor, but I also do research, and the research involves mainly using AI to manage pavements and traffic and bridges. I'm sure when we talk about AI, your first application is not none of these. I'm sure you're thinking of other things than these, but these are the ones I personally have chosen to work with AI in. I think the transportation area is an area where I can benefit a lot from AI or machine learning, and so these are the three main areas I have always worked with when it comes to AI. Now, to the ideal person or the normal person, usually when you talk about AI, um, they have a different perspective. Okay. I've been to engineers, I've tried to pitch my idea about using AI to engineers, and most often the very first thing they'll tell you is, hey, it's going to take away our jobs. No, there's a barrier right there. Um, it's true. AI holds the potential to take away people's jobs. Um,
Yeah.
Now, what I think though is these jobs are jobs that are manual, jobs that are repetitive, jobs that do not require you to think much. Um, Such jobs definitely we can see AI take advantage or take those jobs. But also, I think AI is going to provide avenues for jobs. If you look around, like for instance, data science jobs that are all around, there are a lot of data science jobs that have been created because of this AI revolution. Okay, so AI will not just take away jobs, but I think it will also provide jobs. Um, if you watch a lot of movies, like I do, Terminator, uh, when you think about AI, you think about robots that are out there that are fighting wars. I hope we don't get to this point, but that's also other people's perception of what AI is. Um, if we are very responsible, um, we can use AI to benefit humanity and not destroy it. Um, this is another one. It's actually a video. I tried to just mute it because the words that were coming out was wrong. But
Oh.
this was uh, this is actually not the real Obama. This is a fake Obama. and but you can't really tell that it's fake. So this was generated by an AI, and the words he was saying was also by an AI, but the stuff that were coming out of his mouth is not something that Obama will actually say. So um, we have to be responsible. And actually, you can go to YouTube and Google this. You will be able to see this and actually listen if you want to.
Yeah,
Some of
I
the
saw
things that,
some
that they,
things.
they put there were really not good. So I thought I will not share it. But
Oh my
um,
god.
people can just use you, take you, put words in your mouth, and do a lot of damage. So AI is great. I mean, has the potential, has a big potential to create jobs, but it could also end people's jobs. Um, if we use it responsibly, we will be able to use it to um, help humanity and not destroy it. Okay, so that's those are the things. Now, I don't. None of my work has nothing to do with. So the picture with Obama is actually they call it deep fake. Um, I don't work in that area. I don't work with warfare kind of AI. Um, my AI has to do with pavements and traffic. Okay, so there isn't much harm I can do in this arena. It's pavement and traffic. So anyway, so the only harm I can cause is maybe let cause someone to lose their job, but um, there is so much we can benefit in this area. So today I'm only going to talk about two projects. There are a ton of projects I've done with AI in transportation, but these are two projects I thought maybe one. I'm choosing these because I think it's easy for anyone to actually build something like this at this point. So if, for instance, if you want to design a robot, your own robot, to do some of these things, you can. I think you should have the capabilities to do it. So that's what I'll focus on for today's presentation. These two projects. Now let's look at the first one, which is pavement management. Generally, if you
Mhm.
have different roads and you're an engineer, and let's say the government gives you some money to maintain the roads. Now, how do you use the money? You don't have enough money to fix all the roads in the city. Okay, so what you do is you prioritize. You look at the ones that really needs the money, and then you put the money in there. But to be able to know which roads need the money, you need to go out there and actually look at the cracks, the potholes. Where are the potholes? Where are the cracks? Okay, now this is done manually. Most cities do this manually. So they will go out there, they have their rules, and then they look at cracks. If they see a pothole, they'll measure how deep it is. If they see a crack, they will look at the area of the crack. Um, and now, if you have a really big network, you can do that. If you have thousands of miles of roads, you can't let people
Mhm.
just go around measuring cracks. So usually they will sample. They will take a few of those, a few locations, and then review it. And then once they come up with, they know the condition of all the roads, they will say, okay, I think we're going to go with project one. It has more distresses. It has a lot of potholes. We need to fix it now, else things are going to get bad. Okay. So, and then once they choose the project or the road they want to fix, they can go out there and then construct it. Okay. So this is the pipeline. Um, Now, where can AI come in? That. Okay. Where you have the human being going out to measure cracks and potholes, that's where the AI can replace that. Now, of course, this means that that person is going to lose their job. Um, that's a consequence of it. But the AI is also not perfect. It always
Mhm.
needs to be trained by a human being. So instead of this person going out there to collect data, their job could be training the AI that does this job. Okay, so you can change the way they're working. Instead of them putting themselves at risk going on the road, there are so many safety issues with that. So you're changing the type of job they do. So let the AI do the dirty work, and let the human being train the AI to do its work. And I feel like that's kind of what I'm getting at. So to do this project, what we did is we got a camera, and we use Insta 360, and this could be anything. This, you could use a drone for this. You could use any camera. Okay, we use Insert 360 because we wanted a 360 view of the road and not just the pavement. And then what we do is we basically connect this camera to a computer. So the images that are taken from the camera goes into a computer, and this is a Jetson. So a Jetson is pretty much a very powerful computer. It's a computer with a really powerful graphics card. So those of you who play
Oh,
games, you know what a graphic card is.
yeah.
This Jetson has a really powerful graphics card, and most AI need a graphics card to do its computations. Okay, so that's why we're using this. Now you don't need a Jetson Orin. You can have like the Jetson Orin is expensive. It's about $2,000, but there are other flavors of this that are like actually $99. You can have one for $99, and I'll show you that later. But this is really powerful. The only reason why we use this is we wanted um, the images that are coming from the camera. We wanted to be able to do the processing of the data in real time.
Mhm.
So we want, as we drive on the pavement, we want the engineer to see the condition of the road. If you want real time, then you need a very powerful computer to do that. Anyway, so the images go through a computer, the GPU. That's usually what it's called. And then the GPU finds like potholes. It has the AI in it, so it will be able to find the potholes, all the cracks on the road, and then it pushes the data, the potholes, information, everything to the cloud.
Mhm.
Okay, it goes to the cloud, and then we take the cloud, the information on the cloud, and make a web UI, a web visualization of basically the conditions of the pavement. Okay, so what the engineer really needs is this web UI where it's colored. The roads are colored by its condition. So places where there are a lot of potholes, you will see a much orange, reddish color, and where the
Mhm.
pavement is smooth, it will be green. Okay, so this is the pipeline we used. As I go through my presentation, I know most of you are interested in robotics, so I want to also let you know what kinds of programming languages I'm using in each of these modules. So to pull data from the camera into the Jetson, it's a Python interface. Um, and then from the Jetson, processing the data in the Jetson and pushing it into the cloud, it was also with a Python program. And then from the cloud to the web, it's a JavaScript, TypeScript programming language. Okay, so it's a different mix of programming languages. Um,
Right.
Someone will say, why aren't you using the same programming language? It's really flexibility. What's scalable and all that, and what's you used to your common. I mean, what language you're flexible with. I may know how to use Python for back end stuff, but for web, I don't use Python. I just use JavaScript. Um, Okay, so this is how we set it up. So you can see we have a car, we have a mount with these suction cups. And then we have, if you can see the 360 camera is right there. Um, and then the data is streamed into the Jetson GPU. Okay. And then from there, we have, so the pavement image, okay, has all these boxes on it, which are telling you what types of, it's detecting the cracks. So the AI is basically detecting the cracks in the pavement. Now, if I hit this video, you will notice, and this is going too fast, so I'm going to like stop it so that you can see what's going on. But
Mhm.
in real time, we can tell where the cracks are. So the AI is basically doing that. Now, this AI was trained by a human being. Okay, so initially, a human being will tell it this is a pothole, this is an alligator crack, these are all these cracks. So then you train the AI, and then once it's trained, then it will be able to identify all those cracks. Okay, so this is in real time as we were driving, the AI basically drawing boxes around all the cracks on the pavement.
What? So I see that they're different colors. Does that like?
Yes. So there are different colors. Um, the color represents the type of crack. So we have
Oh.
different types of cracks. So like the one you're seeing right now is called an alligator crack. It
Mhm.
looks like the back of an alligator. So that's an alligator.
Oh.
If it's just if it cuts across the road, it's called a transverse crack. If it's going straight on the road in the direction of traffic, it's called longitudinal crack. And if it's like a box, it's called a block crack. So
Wow.
the color represents the type of crack you have.
And they're at like varying degrees of severity. So if there's like,
Correct. Very
okay.
good. So when you have like the thickness of the crack is the severity, and then we have like extent is how much of the
Oh.
pavement is covered by the crack. So we take all that into
Okay.
consideration. We put all that together,
Mhm.
and then we come up with a map for them. So the engineer doesn't care about any of these things I'm talking about. All he cares about is give me a map that shows where where I need to fix. So the map like this will usually be given them, and so green means you're great. Orange, yellowish mean you may want to fix it. Those sections. So generally they will have something like this, a user interface, and they can zoom in um, and look around and basically find out locations where they're seeing um, like different types of distresses. So you can see on the left side of the visualization, I have alligator cracks. So you
Mhm.
can so this click actually what I did right now here is let me go back. So I clicked on potholes. I checked potholes. So this is showing all the potholes in that city. Okay. So by just so with the UI helps them to know what the location of all the distresses, and then they can go and fix it. And so you can filter all these points by the type of cracks. So this is transverse. So that's basically locations where you can see transverse cracks. Um, and you can actually turn on and turn off. You can look at a satellite view of the map. Um, and let
Uh-huh.
me see. If you click on any of these points, it will pull up the image for that particular location, and you should be able to see basically the images that we actually collected alongside with
So,
the boxes on it.
uh-huh. Is this like information accessible to like a random person? Like can anyone online see it or is it only for like the AI people?
So this is actually given to the agency. So here it will be
Oh, okay.
Missouri Department of Transportation,
Mhm.
and they usually don't want people to see it
Okay, so it's
because
okay.
I think so. When people see this, they will start complaining and say, "Hey,
Oh,
my
good
road is too
point.
bad. Why are you not fixing it?" Um,
Yeah.
so they only keep it in house.
Hmm.
But yeah.
That makes sense. Okay,
Mhm.
thank you.
Okay, so that's the that's basically what we did for that project. And then another agency came in and said, "Hey, I don't want to be mounting these things on my cars. Can you find a way?" And then I want a lot of people to be able to evaluate our paper, like collect data for us.
Hmm.
So I was like, okay, so if you don't want to mount this, then probably the easier way will be to make an app. So can we
Oh
have a
yeah.
phone app that can record the pictures, but also record other things, and then we can take the data that we get from the app and then evaluate the pavement. So that's the next thing we did. Now it's cheaper if it's just everybody has a phone, so it's much cheaper. You don't have to get this
Hmm.
mount. So that's one thing we did. Now for you and me, a road is bad if it's bumpy, right? You go over the road and it's bumpy, and you're like, no, this is a terrible
Yeah.
road, or you see potholes.
Mhm.
Um, the mobile app can actually do that job for you. Um, Now it uses a sensor that we call accelerometer to do that.
Mhm.
Now, just so you understand what this accelerometer does is, now when you push on, if you're driving a car and you push on the gas, it goes forward. That's usually called longitudinal acceleration. Longitudinal, you're going forward. If you're driving and you want to make a lane change, left or right lane change, that's going sideways. So that's usually called lateral acceleration.
Mhm.
If you go over a bump, you go up and down. That's called vertical acceleration. Okay. So there is a sensor in every mobile phone called the accelerometer that can help you get these three things. It can help you with going up and down, bouncing up and down. It can help you with going left and right. So what we did was we just used that sensor. Okay.
Mhm.
So the sensor gives us the vertical acceleration. Okay, and basically what we did is we put it together into an app. Now, if you look at this app, right here I have the location, and then at the right side, hand side, I have the vertical acceleration, which is basically um, is corresponding to the bumpiness. Okay, so if the acceleration, if this plot here goes really high up, it means you hit some bump. Okay, now let
Oh,
me click on this video. So this is basically me driving in my neighborhood, um, and there is something here. There is something here. So
yeah.
watch me as I go over that spot. Watch this plot here, this red plot here, as I go over the spot. There you go. So you see there's a spike right there, um,
Hmm.
which so we can take this information, okay, and then also color a complete map of the city, telling you where the road was really bumpy and where it was not bumpy. Okay, so at the end of a drive, you basically get a map that tells you um, green looks like it was smooth, it wasn't bumpy. Red means it was very, very bumpy. Yellow, it's in between. Okay, so we give them a color map and then they can go in and then go fix the roads based on that.
So
Now, this,
like
yes,
oh sorry, sorry. So it's like instant feedback. So like after you finish your drive, they just like give you a
correct. So this is
wow.
instant, it's real time. Once,
Uh-huh.
once you're done, it gives you this map. It's very
Wow, that's
fast.
crazy.
Now, there's a few issues. So sometimes, if someone is driving in a really really good car, you don't
Hmm.
feel the bumps, so the
Yeah,
phone will also not feel it.
I
And if
see.
someone is driving in a really really bad car, very old car, then even when it goes over something really small, it
Yeah.
feels the shocks. So sometimes that's the issue with this, but it gives you a really great picture of what your pavement
Hmm.
is. Um, this usually we programmed it in Swift, and the visualization is JavaScript. But if you want the one that puts everything in the UI is was done in Swift.
Okay.
Um, now you can really assemble this information really easily. The accelerometer is like $7, and then you can have a microcontroller. I mean, I wouldn't even go for Raspberry Pi because it's expensive. ESP32 is like $7 also. So you can have a accelerometer and then put it on your ESP32, and you actually have something. You add If you add a magnet to it, you can actually put it beneath a vehicle with a magnet. You can attach it to the vehicle on the axles, and you are getting basic. Now the ESP32 has a Wi-Fi, Bluetooth, and all that, so it can also transmit data. So if you have this attached to any of your axles of a vehicle, you can
Hmm.
actually get um, the same information we are getting from the mobile phone.
Okay.
Okay. Even to make it cooler, um, you can put it on a robot. And when it comes to machine learning and I believe the Jetbots are probably the best. They're cheap, easy to build, easy to integrate. So this Jetbot, it's actually now you will have to assemble them by yourself, but they come with parts, and so you just have to
Oh,
put them
okay.
together. It's like any
Yeah.
simple toy the only difference
Hmm.
is this the Jetson. So this is Jetson Nano. This is the GPU. That's about
Okay.
$99.
$9 or
99.
99? 99.
But you
Oh,
don't need this. So if you don't have to do any AI, you don't need this. You can just go
okay.
for an ESP32, which is like $7.
Hmm.
Okay. So if you just wanted to test out the road bumpiness, you can just take an ESP32 and add accelerometer and put it on this board. Um, and you will be able to simulate that, get all those accelerations on this. Now, if you want to do things like use the AI to recognize cracks in pavement, then you need the Jetson, um,
Hmm.
which is $99. Uh,
I
for
mean, it's a
something as
GPU.
powerful,
Yeah.
I feel like it's good for that price.
Yeah.
Yeah. Okay. So lastly, um, this is another project. So this is basically all about the pavement stuff.
Hmm.
One more I wanted to share with is about signal timing. Um, I know you've all been been at the intersection, and sometimes you're like, I wish I got more green on my intersection. Um,
Yeah.
I mean, on my road, on my way. But sometimes you get your green time is really small. How do we actually come up with these green times? Like, who gets, let's say, 20 seconds for green time, and who gets to be on the red for too long? Generally, we have to do what we call counts. Okay, so we
Mhm.
count the movement of cars. So those who are going from east to west, those who are going from west to east, how many cars are going? Okay, so the directions where we have a lot of vehicle, we give them more green time. Okay, another direction where you don't have many vehicles going in. So, for instance, those making, let's say, a right turn here, if there are not very many, then you don't usually get a lot of green time.
Mhm.
Uh, so the challenge though is to be able to know how many vehicles are turning left or right or going through an intersection, you need to count them. Right now, most often you can use clickers. So, like this guy here, he's standing by the intersection
Oh,
and he has a clicker. And then when a vehicle goes left, he press. It's like a game. You press a button, and then it counts it for you.
yeah.
Now, how long can he be there? Generally, you need like at least you need like 3 to 6 days um, of count. So to be able to know like the pattern. Um, but if you just have someone doing this is a pain, and this is just for one intersection, um, and he can lose concentration at any point in time. So that's not something you want a human being to be doing. This is what AI is meant for. Um, so others would just record the video, like what I have on the right side, and then they come home, and then they count on the video manually. Okay,
Mhm.
that's another way to go. But see, there are a lot of tens. There are a lot of tens here, so you can't really count multiple tens at a time. So generally, what will happen is you count one turn and then go to another turn, then go to another turn. It's a pain to do
Mhm.
this manually. Okay, so this is what AI is developed for. Um, what we do is we detect the cars that are going, and then we track them, and then we can count with AI.
Mhm.
Now, detect. I don't want to really go into the algorithms for detecting, but what the AI looks for is it looks for what makes a car. Right? A car has tires, it has windscreens, it has number plates, it has windshields, lights. Okay, so it learns from these features. Okay, and it's so that whenever it
Yeah.
sees something that has tires, that has windscreens, and has mirrors, it knows it's a car. Okay,
Mhm.
so that's basically the detection part. For the tracking part, we track because we want to know if, for instance, this vehicle here, this wine vehicle, we want to know where it's going. So we
Mhm.
need to track it. Okay, so if you look at this, for instance, this vehicle here, now the line behind the vehicle means we are tracking it. Okay, so we know the vehicle came from this place and it was going to this side. It made a right
Yeah.
turn. Okay, so that's really important to do that. Um, Now, once we do the tracking, then we can actually group the movements. Okay, so and
Mhm.
count. So if you look at this, each turn will have a unique color. Okay, I'm gonna click on this, but you will realize that every turn has a different color. So all the
Oh.
vehicles with the same color are going to the same place. They are
Okay.
coming from and going to the same place. Um, Now, of course, it's not perfect. There are a few times when you will see some it may get some wrong, but here it's most often it really gets the. I think there was a little bit of a issue here at the top here with one of the cars, but generally all the cars moving in one direction will have the same color,
Mhm.
and by so doing, we can then tell okay how many went through, how many went right, and then we can time our signal.
Okay.
Here too for the detection we're using Python. The tracking we use C++, and then the counting is Python. Now, we could have done all this with Python. The issue is the tracking can take it takes time. So if you want
Oh.
it to be fast and if you want it to run in real time, C++ is usually the way to go.
Okay.
I think that's pretty much it. I think I showed you a project on the pavement side, and then another on with the mobile app, and then I showed you something on traffic signal timing. But that's generally my only, especially since you're grooming yourself to be robotics people. One thing I will say is never restrict yourself to one programming language.
Mm-hmm.
Um, it's good to be versatile. At this point, you learn how to program languages. It's no point just sticking to one particular language,
Yeah.
especially as I mean, with time, you will get more, I mean, better programming languages. So learn how to program a language. There's no need to just get stuck to one particular language. Right now, with machine learning, Python is kind of the one to go, but don't
Mm-hmm.
restrict yourself. Okay, I think that's pretty much all I had. If there are any,
Okay. That was amazing. Thank you.
you're
It was
welcome.
really interesting. Okay, we have a few questions. So the first one is, what are some of the advantages and disadvantages of using Python and JavaScript compared to other languages?
The advantages of using Python and JavaScript.
Mm-hmm.
Um, so so Python is slightly slower than C and C++. Um, the only thing is development time. So Python is it's how will I call it? It's easy to learn.
Yeah.
Okay, so when you're writing codes, you can quickly write codes with Python within a shortest possible time. C might take you some time. Um, so I will usually use Python if I need to get something done quickly. Um, if speed is really not a big issue, I would just go with Python. Um,
Okay.
JavaScript. So I'm now shifting from JavaScript to TypeScript, but JavaScript is also it's I think JavaScript is pretty similar. I mean, it's easy to use. For web, I will always go with it. If it's web development, I will usually
Okay.
just because most of the good frameworks for web development are based on JavaScript. So that's usually one reason, especially if you don't want to program everything from scratch. Like there are programs like React, um, other frameworks that are just built on top of JavaScript
Mm-hmm.
that you wouldn't have to spend so much time trying to program everything from scratch. So I usually just go with JavaScript in that case.
That makes sense. Okay. Thanks. There's another question. How long would the process of the first project take, or like what would the timeline be?
Good question. Um, so it depends on who I'm doing the project for. Um, if it's a city, generally it doesn't go beyond a year. Um, if it's the state, that usually is like between 2 to 3 years. Now the pavement one, the one with the mobile app was 6 months. So from start to the end to deliver the app, and then for them to be able to get everything, it was 6 months. It took us about 3 months to build the whole thing, and then the remaining 3 months we had to go back and forth with them. So you have a UI. Sometimes they're like, we don't like the way the UI looks. Can you change this? So we went
Um,
back and forth for the other 3 months. Um, the traffic signal one, that was about 2 years. Um, sometimes the state has more delays because there are a lot of bureaucracies to go through. But with doing the project itself, if you had everything, you will get. I mean, usually within a year we will
mhm.
get it done. But sometimes the bureaucracies will take it a bit longer.
Okay, makes sense. Other one says, how accurate is the AI?
Very good question. Um, for pavement, so usually we have a metric.
Mm-hmm.
Um, we have precision. So if the AI says, okay, this is an alligator crack, how likely is it that is actually going to be an alligator? So we have a precision measure for that. Um, with the pavement one, I think we were doing between 80 to 90%
Mm-hmm.
accuracy. Um, so, but it also sometimes depends on the time of day. So if it rains, you actually sometimes don't see the cracks. or if there's a
Yeah.
shadow on the pavement. So if
Uh-huh.
there's a tree casts a shadow on the pavement, it's very difficult for the AI to tell the cracks.
Hmm.
Um, so the condition matters. Of course, if there's snow, then don't even go out there. There's no way you're gonna see anything.
Yeah.
But yeah, it varies.
That's basically the next question, which is how does extreme weather conditions affect the data collection process?
Yep.
Do you have
Um,
anything to add, or is that
no, I mean, pretty much if it's I would so there have been cases where we will train it for extreme weather, but my because what happens is when you train it for extreme weather, then even it may do fine in extreme weather, and then during normal conditions it starts to not do well.
Mhm.
So generally, I will just say for extreme weather, don't go out, don't go do any.
Okay.
So for pavement, don't go do any data collection. I mean, when the weather is extreme. For the signals, the same thing. Collect your data when you've got good data. I mean, a good day.
Okay.
Mhm.
This next one. What made you interested in traffic operations, or what are you doing now? Current projects,
Traffic
maybe.
operations. So um, it's because of data. So my PhD was mostly in the pavement area.
Hmm.
Um, but and I wanted to work with big data and AI, but we didn't have much data there then when I was doing this. The traffic operations people had a lot more data, and they had real-time data. So usually you'll see around there are CCTV cameras all over. All that data goes into traffic operations. So the data was there to do AI,
Yeah.
and that's was the reason why I went in there. Um, it was just it was easy to get data to test my algorithms. Um, but yeah, I feel like
Okay.
that was the primary reason. There was data.
All
Um,
right.
yeah.
Um, this next one. We have quite a bit of questions. Is the vehicle recognition library publicly available? Is that the website that you were showing earlier?
Um, so mine is not. Now I have codes on my GitHub page, but there are like so PyTorch has vehicle recognition models available. It's for free. You can pick them
PyTorch?
up. Yes. So PyTorch is a framework that is used to build deep learning models, and they have like a lot of good models that you can use to recognize vehicles, free of charge. And it doesn't only just recognize vehicles; it can do a whole lot more. Um, so check it out. PyTorch, it was developed by Facebook.
Oh, I think
But
I see it.
yeah,
Yeah. Is it PY Torch?
yes, PY
Okay.
Torch. Yes.
All right. Thank you.
Mhm.
Um. Okay. Next one. How do you how do you identify the cars that will turn before they actually turn in the video?
That's a really good point. So it's based on where. So the um, on the ground, there are certain lanes when you get in, you will have to turn.
Oh, the turn lanes, right?
Right. There are 10
Yeah.
lanes. So it's based on the lanes that they're in. Um,
Okay.
Without it, there's no way.
Okay.
You have to,
That
yeah,
makes sense.
there's no way to do that. It's based on the 10 lanes.
All right. Um. This one kind of aligns with the previous question. How much data do you use, and how do you get access to the data?
I was actually a lot. So for instance, the traffic videos, um, we had to collect to be able to train the model to actually recognize vehicles. We had to get about, I think we had over 300 intersections, videos from 300 intersections, and it
Wow.
was at different days.
Uh-huh.
So we had mornings, sunset, sunrise, snow, on different weather conditions. So it was a lot of data.
Wow.
The pavements, we actually, what we did was we took a vehicle and surveyed almost all the roads in Colombia, the city I live in, um, and trained the models based on that data.
Hmm.
So which and that's a lot of data. Um, we're talking about maybe 200,000 images to train the model.
Wow.
Yeah.
I see. That's crazy. Okay. Another one. How does the AI adapt to different lighting for various times of the day?
So if you wanted to adapt to different lighting conditions, then you need to actually give a data set and the different lighting conditions. So all the AI is doing is finding correlations, is finding patterns. Okay, so
Okay.
if it hasn't seen, let's say, images from sunrise or sunset, it will usually fail embarrassingly. When you give it you give it a video and there's a sun cast in the background, it will completely
Mm-hmm.
fail. So if you wanted to be able to do that, all you have to do is collect more data, and then let someone tell it, okay, so this is a sunset, these are vehicles, and draw boxes around vehicles. Now once you give it that information, it will be able to learn that. Now, and you also want to make sure your data is not all sunset and sunlight,
Different.
because
Yeah.
what happens is you have other conditions to learn for, right? So you don't want one condition to dominate over the other. So
Yeah.
different times of days, you may have to make sure that you have sufficient data for all the conditions you want, and that will help it to learn.
Okay. And this is the last question. What is the scale of the traffic project? Like, is it for a few intersections or a whole city? Or is it over a different, like, yeah.
So yes, so right now this is deployed for St. Charles City, which is in St. Louis
Mm-hmm.
district. It's so this is a city, and then the DOT uses it when they need it. So if they need to collect tandem movement count data for a particular intersection, they just turn it on and off. Um,
Mm-hmm.
but one city uses it all the time.
Okay.
Yes.
Yeah. Okay, I think that's it. Thank you so much for this presentation. I actually learned so
Okay.
much. Wow. Do you have anything else to add? I'm really grateful that you took the time to come speak with us about this today.
No,
We-
it's great to be here.
Okay. I think that's it then. Thank you everyone for tuning in and asking these great questions. Professor Yaw, thank you so much once again. This was amazing. Okay, is that it?
All right.
All right, thank you everyone. Goodbye.
Bye bye.